Introduction. In our previous classes, we have learnt about natural numbers, their properties, etc. In this chapter, we will learn about whole numbers, their properties, and some patterns related to them. Numeral. We know that each and every collection can be associated with a number. We can associate number 1 with a single object, number 2 with 2 objects, and so on. Thus, a number is a concept or an idea. Different civilizations like Indo-Arabic, Devanagari, Arab, Romans, etc. used different symbols to denote numbers. The symbol which represents a number is called a numeral. The numerals which are used in counting objects, that is 1, 2, 3 and so on, are called counting numbers or natural numbers. Predecessor and successor. Predecessor, one less than a given natural number, except 1 is called its predecessor. Example, 16 is a predecessor of 17. Successor, one more than a given natural number is called its successor. Example, successor of 24 is 25. We observe that every natural number has a successor. Thus, we cannot find the largest natural number. Whole numbers. Natural number 1 has no predecessor in natural numbers. We know that 1 minus 1 is equal to 0. Hence, 0 is the predecessor of 1. But 0 is not a natural number. So, 1 has no predecessor in natural numbers, but has its predecessor in whole numbers. To the collection of natural numbers, we add 0 as the predecessor for 1. The natural number along with 0 form the collection of whole numbers. Note: A. All natural numbers are whole numbers. B. All whole numbers are not natural numbers. C. We cannot find largest natural or whole number. D. 0 is the smallest whole number. E. 1 is the smallest natural number. The number line. Number line. Draw a line. Mark a point 0 on it. Mark another point to the right of it. Label it as 1 and then mark equal distances to the right of it. Label the points as 0, 1, 2, 3 and so on. This is a number line for whole numbers. We can compare, add, subtract and multiply on number line. Comparison of two whole numbers. As we move to the right side of the number line, the number increases. To compare two whole numbers, we locate the numbers on the number line. The number which lies to the right of other is a greater number. We can also say that whole numbers on the left side of a number are smaller than the given numbers. Example, 7 lies to the left of 9. So, 7 is smaller than 9 or 9 is greater than 7. As it lies to the right of 7. Addition on number line. Addition of whole numbers can be shown on number line. To add 3 and 7, we locate 3 or 7 and then move 7 or 3 steps to the right side. Therefore, 3 plus 7 is equal to 10. Similarly, we can represent 7 plus 3 is equal to 10 on number line. Subtraction on number line. Subtraction of whole numbers can also be shown on number line. To subtract 3 from 7, we reach at 7 and move towards left 3 steps. A. From 0, first we reach at the number 7. B. Move 3 steps to the left of 7. That is, therefore, 7 minus 3 is equal to 4. Multiplication on number line. We know multiplication is repeated addition. Multiplication of larger numbers require multiplication tables. Smaller numbers can be multiplied on a number line. To find 3 multiplied by 2, we start from 0 and move 3 units at a time. Make 2 such moves to reach 6. Or we can also start from 0 and move 2 units at a time and make 3 such moves to reach 6. Solved examples. Example 1. Which whole number of the given pairs lies to the left of other? A. 503, 305. B. 567, 675. Solution. A. Compare the numbers. Since 305 is lesser than 503, so 305 lies to the left of 503. B. Compare the numbers. Since 567 is lesser than 675, so 567 lies to the left of 675. Example 2. Write the successor of the following. A. 20,999. B. 2,34,560. Solution. A. 20,999 plus 1 is equal to 21,000 is the successor of 20,999. B. 2,34,560 plus 1 is equal to 2,34,561 is the successor of 2,34,560. Example 3. Write the predecessor of the following. A. 10,900. B. 23,900. Solution. A. 10,900 minus 1 is equal to 10,899 is the predecessor of 10,900. B. 23,900 minus 1 is equal to 23,899 is the predecessor of 23,900. Properties of whole numbers. 1. Closure property of addition and multiplication. When two whole numbers are added or multiplied, their sum or product is again a whole number. That is, whole number are closed under addition and multiplication. Example, 2 plus 5 is equal to 7 and 2 multiplied by 5 is equal to 10. 2. Commutative property of addition and multiplication. Two whole numbers can be added or multiplied in any order. The result will always remain same. Example, 2 plus 3 is equal to 5 and 3 plus 2 is equal to 5. Therefore, 3 plus 2 is equal to 2 plus 3. Similarly, 2 into 3 is equal to 6. 3 into 2 is equal to 6. Therefore, 2 into 3 is equal to 3 into 2. This property is known as commutative property of addition or multiplication. 3. Associative property of addition and multiplication. If A, B and C are three whole numbers, then A plus B plus C is equal to A plus B plus C, which is equal to A plus C plus B, and A into B into C is equal to A into B into C is equal to A into C into B. Thus, we conclude that the sum or product of three numbers remains the same irrespective of the grouping in any order. Example, 10 plus 20 plus 30 is equal to 10 plus 20 plus 30, which is equal to 10 plus 30 plus 20, which is equal to 60. Or 10 into 20 into 30 is equal to 10 into 20 into 30, which is equal to 10 into 30 into 20, which is equal to 6,000. This property can be used to group the addends or multiplicants to simplify the calculation. Example, to add 267 plus 564 plus 733, we add 267 and 733 first and then 564. That is 267 plus 564 plus 733 is equal to 267 plus 733 plus 564, which is equal to 1000 plus 564, which is equal to 1564. 4. Distributive property of multiplication over addition or subtraction. If A, B and C are three whole numbers, then A into B plus C is equal to A into B plus A into C, and A into B minus C is equal to A into B minus A into C. This property of whole number is called as distributive property of multiplication over addition or subtraction. 5. Division of whole number by 0. Division by a number means subtracting that number repeatedly till we get 0 or a number less than the divisor. That is, 8 divided by 2 means 8 minus 2, 6, minus 2, 4, minus 2, 2, minus 2, 0. So, 8 divided by 2 is equal to 4. Let us try 2 divided by 0. 2 minus 0, 2, minus 0, 2, minus 0. Thus, we conclude that this process will always have 2 as we continue subtracting 0 from 2. We will never get 0 or a number less than 0, so we can say that division by 0 is not defined. 6. Additive identity of whole numbers. Let A be any whole number, then A plus 0 is equal to 0 plus A, which is equal to A. Thus, 0 is the additive identity of whole numbers. 7. Multiplicative identity of whole numbers. Let A be a whole number, then A multiplied by 1 is equal to 1 multiplied by A, which is equal to A. Therefore, 1 is the multiplicative identity of whole numbers. Patterns in whole numbers. Let us now learn to arrange numbers in elementary shapes made up of dots. We will learn to arrange them in any of the shape given below. 1. A line. 2. Rectangle. 3. Square. 4. Triangle. 1. Every number can be arranged as a line. Example: number, pattern, 2, 3, 1, 5, 2. Some numbers can be arranged as rectangles. Example: number, pattern, 6, or 8, or 10, or 12, or 3. Some numbers like 4, 9, 16, 25, etc. can be arranged as square. Number, pattern, 4, 9, 16, 25. 4. Some numbers can be arranged like triangles. Example: 3, 6, 10, 15, etc. Number, pattern, 3, 6, 10, 15. Example 1. Some numbers can be shown as rectangles in two ways. One such example is shown as 12, or 4 into 3 is equal to 12, or 6 into 2 is equal to 12. Give at least 2 other such examples. Solution: A. 18, 2 into 9, or 3 into 6. B. 20, 2 into 10, or 5 into 4.